Hello everyone, and welcome to section 12.9, which is talking about inverse trig functions. We have done a little bit from this. This is when we are looking for the angle when given a ratio. So problems in this section are going to fall into one of two categories. One's referencing the unit circle, so our trig hand jive and quadrantal angles, or they're going to throw a random ratio at you and you'll use a calculator to figure it out. And we're going to look at both. Our answers for these inverses are going to be interesting, so they're going to either give us in an arcsine slash inverse sine or arctan slash inverse tan. Both phrases are used interchangeably. Your call which one you want to use. If it's positive, it's going to be in the first quadrant, and if it's negative, it's going to be in the fourth quadrant. For our cosine or inverse cosine, it's going to be in the first and second quadrant, with positive being in the first quadrant and negative being in the second quadrant. And that all does follow, the fact that we've got ASTC, sine and tangent are negative here, cosine's negative here, so it just kind of gives us our whole span of positive and negative angles. So our domain, what we can take the inverse of for sine and cosine, it can be anything between -1 and 1, including those numbers. So I would never ask you for the inverse sine of 3 and expect to get you an actual answer. And then our answers fall into these quadrants. For arctangent, because it does go on forever, both in the positive and negative infinity direction, you can actually take the inverse tangent of anything. So, let's look at the note calculator part first. So, evaluate the expression in both radians and degrees. So, if I'm looking at the inverse sine of root 3 over 2, I see, first of all, I'm positive, so I'm going to be in the first quadrant. I need to figure out what my angle is. Now, the finger I can put down to get square root of 3 over 2, to kind of go backwards with the trig hand jive, is my index finger. I'm an awful artist, but you get the idea. So if we put down our index finger, we have square root of 3 over our palm of 2. So my angle with my index finger is 60 degrees. Since I'm in the first quadrant, I don't have to change anything. And 60 degrees in radians is pi over 3. For inverse tangent of -1, I see that it's negative, so I know it's going to be in the fourth quadrant. The finger I would put down for tangent to get 1 in general would be my middle finger. Again, awful artist, but you get the idea. So we have square root of 2 over square root of 2, which is 1. So that angle, if we flip our hand back over, is our 45-degree angle. So that's our reference angle. So you would either say -45 and negative pi over 4, or give the actual positive answer if you feel comfortable with that. So that would be 315 and 7 pi over 4. If you just feel comfortable with making it negative, that's fine, since they are coterminal angles. Another one, so if I'm looking at the inverse cosine of -1/2, so I'm negative. Cosine is negative in the second quadrant. So, since cosine's above, the finger I put down to get 1 over 2 is my index finger. So I have a reference angle of 60 degrees. Because I'm in the second quadrant, I can't just say -60. 60 degrees above the 180 would be 120. And as a radian, since I know it's a denominator of 3, it's almost 1, so 2 pi over 3. Or you can just convert that by multiplying by pi over 180. If I wanted the value of arcsine at -1, so I'm thinking to myself, well, arcsine, so that's the right-hand side of my circle. Sine is my y value in my unit circle. So where is my sine? -1. It's at the 270/3π/2. Or if you feel more comfortable saying -90 and -π/2, that's fine too. So for the quadrantals, you're just asking yourself, alright, well, am I finding an x or y value, or a y over x if it was inverse tangent, and then where in the world in my circle is that going to be? Keeping in mind our quadrants, of course. And now our calculators. So these problems, it'll hopefully be pretty obvious because it'll say something like round to the nearest hundredth. And also it's just going to look really ugly. So find the value of tangent of inverse cosine of 4/7. So you could do the inside first and then take the tangent of that answer, but if you've got a graphing calculator, you can just type it straight in. So if I take out the calculator, I'm going to make sure that I am in degrees. For those of you that may have had to change batteries recently, it might be good to check. So I want the tangent of inverse cosine 4/7. So I get about 1.44. And that would be my answer. I get it straight from the calculator. I just have to make sure my calculator is in degrees. I don't have to convert that to radians. It just is what it is. So if the sine of theta is -0.707, find theta. Same idea. So I'm going to do the inverse sine of that -0.707. My angle is about -45 degrees. If you want to convert that to the coterminal, feel free. But like I said, the negatives are fine. And back to kind of like our SOHCAHTOA stuff from the first section in this chapter. We could be given a diagram. To find the angle, we always do the inverse sine or cosine or tangent anyway. So to find this angle, I see this 8 is the opposite, 20 is the hypotenuse. So I am going to do inverse sine of 8/20 equals theta for my right inverse trigonometric function, and just type that into my calculator. And I get about 23.6 degrees. And that's about it. So some of these will be with calculator, others will not be.